So here's a quick video on derivatives of logarithmic functions. I'll give you the formulas, which you just need to know, and then I'm actually going to take a little bit of time to go over a couple example problems from the homework, or at least from the section. So first thing that you need to know is that the derivative of the log base something of x, that's an a by the way, is equal to 1 over x times the natural log of the base of the logarithm. Now, one specific application of this would be for the natural log. Now, natural log of x, you'll recall, is log base e of x, right? So let's think about what would happen if we did the derivative of the log base e of x. Well, we would have 1 over x times the natural log of e, which, if you'll recall, is 1. So x times 1 is just x. So really, all we need to do for the natural log is say 1 over x. Now, just real quick, if you're thinking in terms of, well, what if I have a chain rule? So if we have the derivative of the natural log of u, and if you recall, u and v is what I always use to indicate some sort of function of x. So u is some sort of function of x. So the derivative of the natural log of u would just be 1 over u times whatever the derivative of u was, u prime. So let's take a look at a couple of specific problems and how these formulas work out. So, you know what? I'm going to go with number 5 here first. So if I've got log base 2 of 1 minus 3x, what that's going to come out to be, the derivative, f prime of x, would be 1 over what I have inside of my logarithm. Now I need to take that times the natural log of the base, which was 2. Now since this right here is actually a chain rule as well, I need to multiply then by what's the derivative of what's inside of my logarithm to begin with. So the derivative of 1 minus 3x, well, the derivative of 1 is 0. The derivative of negative 3x would just be a negative 3. So instead of writing the negative 3 there, what I could do is I could bring it over on top here. And that would be the derivative for number 5. All right. Now, let's take a look at, I think number 9 was highlighted and then I erased it. This is a good one because it's got a product rule thrown in and a couple of interesting things going on. So when we have the product rule, as you'll recall, that's when you have the derivative of one function times another, u times v. So in this case, u is sine x, v is natural log of 5x. So the derivative, well, it's u prime v. So the derivative of the sine of x is the cosine of x times natural log of 5x plus u, so sine x, leave that alone, times. Now, the derivative of the natural log of something is going to be 1 over the something times the derivative of the something. So we have 1 over 5x times the derivative of 5x, which is just 5. And simplifying things ever so slightly, I get cosine x, natural log 5x, plus, well, these 5's over here can actually cancel each other out. And what I would end up with is sine x over x. And that would be my answer. All right, I hope this quick video helps. If you have any questions on derivatives of logarithms, let me know. It's going to be the same thing as we've been doing all along. It's just another rule, another tool to add to your toolbox, but we're going to be using them all for the same things. We're going to be finding derivatives of functions, slopes of tangent lines, equations of tangent lines, rates of change of various word functions, and that sort of thing. One other quick little example that I want to use over here. This is where logarithmic differentiation and logarithm rules actually become really helpful. You can simplify some of these problems to actually find the derivatives. So, you know what, I'm going to take on number 40 over here. So number 40 is interesting because we have a variable in my exponent. So what I'm going to do is I'm going to rewrite this as the natural log of y equals the natural log of the square root of x to the x power, or x to the x to the 1/2, which is actually going to come out to be x to the x over 2 power. And if you're not entirely sure why that's the case, let me know. It's just simple exponent rules. Okay, so now at this point, what I need to do is I need to take the derivative of this thing, and I'm going to do implicit differentiation. So the derivative of the natural log of y is going to be 1 over y times y prime equals, well, okay, hold on, actually. I need to simplify this a little bit more, and to do that, I can bring this x over 2 down in front as my coefficient. And actually, you know what? I don't really like that's written as x over 2. That's the same thing as half x. There we go. I like that a little bit better. Okay, now what we can see is we have a product rule. We have u and v. So the derivative of 1/2 x is just 1/2. So we have 1/2 times the natural log of x plus 1/2 x times the derivative of the natural log of x is 1 over x. Simplifying a bit, those x's actually cancel each other out, and so we have 1 over y times y prime equals 1/2 natural log of x plus 1/2. Now, I don't like that I have this 1 over y over here. So what I need to do is I need to multiply both sides by y. And if I go back to originally what I had, y is the square root of x to the x power. So if I multiply both sides by y, that cancels out, and I get y prime equals, and what I'm going to do is here at the end, I'm just going to replace it with what y was equal to, square root of x to the x power. And that would be your answer right there. And that's what you could use to find the slope of a tangent line, to find the rate of change of a particular quantity in a function. You can also find the equations of tangent lines and things like that. If you have any questions, let me know.